What happens when a person moves from pole to the equator? Suppose this is the axis about which the earth is rotating. If a person moves from pole to the equator, what happens to the centripetal force? Centrifugal force experienced by a person on this rotating frame is a force away from the center. When this is rotating, if a person is here, he will experience a force away from here. When he is near the equator, he goes in a greater circle. So here this circular track has a greater radius. Here this circular path has a smaller radius. But here also, because the earth is rotating once in 24 hours, here also the person goes around once in 24 hours. So his angular velocity at near the pole and angular velocity at the equator both are same, but the radius near the pole is less than the radius near the equator. But we know that centripetal force F is equal to mv square by radius r. But V is equal to r omega, m into r omega whole square by r. So centripetal force is equal to m r omega square. Then the magnitude of centrifugal force is also equal to m r omega square. But a person near the pole, not exactly at the pole, a person near the pole or a person near the equator, they both have same omega, they both have same mass, the only difference is radius. But at the equator, radius is more, then force near the equator is m into r near the equator, m into radius near the equator into omega square. Force near the pole is m into radius near the pole into omega square. When you cancel this, what you are having is radius near the equator by radius near the pole. Since this is greater than this value is greater than 1, hence Fe by Fe is greater than 1. So force near equator by force near the pole is greater than 1, hence force near the equator is greater than force near the pole.